Okay, so I'm Yotam. As I started saying before things kind of got out of control, I lead the research at a AI security startup based in Israel called Pluto Security. Before that, led research teams at Zscaler, PayPal, also data science, machine learning. Been interested in the AI security space since before it was called AI security, when it was ML security, adversarial examples, and all that fun stuff. And today we're going to talk about deception. So before I start, as I kind of was doing the research for the talk, I ran into a Reddit thread from 2 weeks ago from a guy that basically connected a Raspberry Pi and made it pretend to be an RTX GPU. And he was kind of talking about some of the stuff that he came across, that he found, which was interesting to see, or to read. So he said that within 3 hours it was already indexed by Shodan, and the first probe that he got was in less than an hour. Throughout 30 days, 113,000 requests, and 23% of them specifically targeted AI. So this is kind of background to some of what I'm going to discuss today. And I assume that you don't need me to tell you that we're kind of at an inflection point when it comes to AI capabilities and what it allows attackers to do, also defenders, but you'll hear me talk about that a lot during the talk, this kind of double-edged sword principle, dual use of any AI technology. And I think that at the current moment, attackers might have the upper end, and hopefully by the end of this talk, you'll see that there are some creative things that we can do using AI to kind of get a step ahead of attackers. So yeah, these are just a few examples. I don't know how well you can see, but yeah, we know, okay, AI Expo became the #1 ranked in HackerOne, basically an AI pen testing company. But we also had reports from Anthropic about in the wild use of AI to scale up attacks, to make them more modular, and it lowers the bar for attackers and allows more effective attacks from the from the attacker side. And kind of the last box on the right, I'll touch on it a bit later, but basically those are research that is focused on both from Grey Noise and also another Israeli startup called Pillar Security that set up honeypot infrastructure, specifically targeting and tracking AI-based traffic. Who here has ever set up a honeypot, had experience with it? Just a show of hands. Okay, so we have quite a few. So, as you know, this isn't a new term, right? And in the old days, usually it was meant to kind of trigger or catch two types of traffic: human attackers, and malicious botnet, malware, worms, etc. But what we're seeing now is that it kind of shifted. It's not really discussed, but because the scale of compute has gone so much up, it's currently used more as an analytic kind of infrastructure than it is as a deception mechanism. So you see the stat here, like 99.2% of traffic is just automated scanning scripts mapping the internet, trying to identify targets, and obviously there are open source or commercial platforms that do that as well, like Shodan and Sensis and others. And the thing is that in the last couple of years we're seeing a shift. We're seeing that a lot of the traffic that is generated is not AI or malware, it's either AI assisted traffic or just AI agents. And this is growing, but the problem is the term here, the data desert, is from a paper. I'll link them, all of the references in the end, but basically they talk about the fact that all of our data for analyzing and building these endpoints is obsolete. It's from 2015. All of the data sets are old, and it's not really portraying the current state of malicious traffic. And this will only grow, this gap. So these are some numbers. You see on the left-hand side kind of the AI offense, which I mentioned. So Expo has a benchmark of how well an AI does on offensive or I wouldn't say, let's say cybersecurity tasks. There are a lot of different benchmarks, but this is based on that. So they scored a 91 on their own benchmark, which is kind of okay. But then it kind of became the standard in the industry. So then we have Shannon, which is also kind of an AI pen testing open source product, which scored a 96. And then on the other hand is more about the upper one. We see the advantage of using AI as a honeypot. It allows you to run more commands per session. We'll talk about that in a little bit, but also how LLM are convincing humans. So basically it's a flip of a coin for human to know if something that he reads or interacts with is LLM based or human generated. And this is kind of the core of what I want to focus in this talk. Again, I'm a big fan of the dual use of AI systems. So I'll touch about two things, two sides of the equation. One, how do we use AI to actually create the bait, create these honeypots, and what are the advantages that it gives us? And on the other hand is how do we use AI to actually deceive attackers or catch them? Honeypots in general, so I kind of divided it to two axes. How convincing it looks, and what are the operational costs. So on the bottom left-hand side, you see static web honeypots, so just serving static content. So it's really cheap to manage, to operate, but it's not really convincing. Attackers or AI systems that are interacting with it will quickly understand that this isn't a real target. On kind of the other end of the spectrum, we have actual real systems that people are setting up there. So it's not mimicking something, it is the thing. But obviously it comes with operational costs. And we have like Curry and Teapot, which are products that are, again, they're still fingerprintable, but they do a better job than static honeypots. And kind of the advantage of LLM-based honeypots is that they are able to become very convincing, but relatively in a low operational cost. So these are a couple of tools that are out there for creating these honeypots. So one is, I hope I'm pronouncing it right, but Beelzebub by Mario Candela. It's open source. It started out as a side project, but really kind of caught on. And again, no funding behind it, but this is one of the most popular project in this domain. So basically we have the attacker payload. It goes through some kind of proxy listener interface, and then it goes through an LLM router to whatever LLM that the tool supports, basically most of the ones that you know. And then the LLM receives the input, generates an output, and it also has a mechanism to kind of save the session history, so you can track and see what happened, the interaction. And it also has now MCP support, so it can also simulate MCP servers or track. Another one that is also popular, this one was by Adel Karimi. It was introduced at DEF CON 2024, so also kind of early to the trend. It's much more capable at the moment. But the same kind of principle, what it prides itself on is that it doesn't, it doesn't have any pre-template. So every response is generated on the spot by an LLM. And the thing is that even if a human attacker stumbles upon these things and starts to interact with them, then there's a blog that Mario wrote, the developer of Beelzebub, that you see that it interacts with it as it would with any other instance. So it does scanning, it does, it kind of checks, mapping out what are the attacks and getting legitimate response. By the way, not always. So if you're keen-eyed, you would notice some discrepancies between interacting with an actual shell. Often it depends also on the model that is used, etc. But generally speaking, it's something that is that even human attackers will have a hard time of detecting that they're not interacting with an actual thing. So some numbers. You look at the numbers. I'll take a sip of water. Okay, so basically we have two kind of attack surfaces, I would say, that emerged in terms of populations of honeypots. One is vibe-coded apps that, as you know, especially as they started out, so we're talking, you know, the Lovables, Replits, Base 44s of the world, and more and more and more, but they also don't have a lot of security hygiene, at least when they started out, so they're kind of appealing targets, and they're very widespread. And the other type is the infrastructure, so MCPs, LLM proxies, all sorts of kind of the infrastructure layer of AI, and the reason that they are targeted is mostly because of their monetary value. So there's a term called LLM jacking. Anyone heard of it? So basically it means that you're hijacking sessions, tokens from an LLM or an account that isn't yours. And this is becoming highly popular. So the 50K number that you see here is basically monetization. This is from Assistic research of LLM jacking. So basically a single endpoint, an OpenAI endpoint, burned through $50,000 in tokens in one of the attacks. But it is kind of important to note that this is what it cost the victim. It's not that the attacker doesn't gain $50,000. It's not, so they're using the tokens for something else. In this case, they had a service that they sold kind of $30 worth of tokens in shady places. So that's kind of the other side of the of what we're seeing in that sense. The 35K number is from a different research from Pillar Security. They also set up kind of this infrastructure, and they saw this number of sessions going through the system. And throughout these systems, if I'm going back to it's actually relevant both for the vibe coding apps and also for the LLM infrastructure. This whole ecosystem is new. It's not really security mature, and that's why it's targeted. So we are seeing the same kind of patterns, lacking authentication, exposed secrets, insecure defaults. There is something that is kind of across the board, and as of today, like currently at least, this is the way it is, and this is why it's also heavily attacked and successfully so. So it's not, and the point I want to make here is it's not, I don't want to, vibe coding is bad or, like I said, it's slowly maturing, but from an attacker's perspective, this is what they target. So if we know that this is what they target, we can also take advantage of that as defenders, and when we are building these honeypots, this is something that an attacker will see and say, oh, that's interesting. So that's what they're looking for, so we can take advantage of that, right? So how do we actually go about it? So basically, we use an LLM. We set up kind of a prompt that set up this decoy, whether it's an infrastructure layer or an AI app. And in this talk, I'll show a couple of examples of applications. And then we need to somehow deploy it somewhere that is publicly exposed. And wait, it's not rocket science. So pretty simple in that term. The hard part is not actually setting it up so much as how do we make it believable? How do we allow the thing to behave in a way that is credible once it's being interacted with and kind of mimic different broad set of services, etc. But the principle isn't, it's not very complex. So the first example that we'll show, so not exactly a demo because I don't want to mess with the demo god, especially not after what happened earlier. So luckily it's a recorded video, but if we'll have time, maybe we can play around with it at the end. So here I'm using the same Bizlebub thing that I mentioned, open source, and just a local model, Olama, really small. Anyone can set it up on their laptop. It's here right now as we're speaking. Really simple and really cheap as well. So what you see here, so basically this is just an interaction of the attacker with the thing. So every command that you see, you say it typed cat etc password. It took some time because the LLM needs to think, okay, I need to generate it now and make it look believable. So again, it's not for a human. Something might smell fishy, but as a bot, as a script, as an AI agent, you don't pick up on these things. So basically, everything that you see or all of the commands are interaction not with an actual shell, but with an LLM. So as I said, cost almost zero, but you can see some discrepancies. So when it traverses like the tree, that's not the output that you would see. It's cut off. Sometimes the order of commands is off. Sometimes you'll see dates that are not really aligned or kind of obsolete. But still, again, it looks pretty credible. And a static honeypot wouldn't be able to be this flexible and look so believable unless you you invest significant effort in allowing it to get to a point like that. And it's more like templating, kind of regex, kind of logical ways to, okay, what are the type of responses that I get? What do I need to simulate? Again, and I'm not talking about there are honeypots that are like the actual thing, as I mentioned, but these have a disadvantage of being more expensive to operate. Okay, so this was actually the easy part, and I think now we're getting to the more interesting or fun part, at least from my perspective. We have used AI to set up these decoys. Okay, nice. And we understand kind of what they give us as defenders and the advantages they provide. But can we use the same kind of technique, the same decoys, to also catch the bad guys, to catch AI attackers, to fool them? So this is, I think, the more interesting aspect. So going back again to the loop thing, I don't know if it's the best, but that notebook LM chose to portray it like that, so I'm with it. But basically, again, I want to emphasize again, everything here can be used by attackers and by defenders, and I think one of the things that we as defenders need to think about is we have this asymmetry. Attackers are now utilizing AI. We need to think about how do we, as defenders, threat model that and defend against that current threat. So we can exploit like the very fact that the attacker is in AI can play at our advantage. And that's what we'll be exploiting here. So, and a bait that might look, again, fishy, weird to a human, usually won't necessarily seem that way to an attacker. And one last thing, that the reason that it works so is because the LLMs are trained, evaluated, based on signals. They a lot of what goes into it is also reinforcement learning, human in the loop. I won't go into it too much, but basically they are given a reward whenever they do an action that provides value. So if that model now, its target is to find credentials, and it finds something that looks like a credential, for it, it's a positive reinforcement, and it will continue going down that route because it's a positive signal. And this is exactly what we'll take advantage of. So there's a kind of mental model coined by Simon Wilson called the lethal trifecta. Has anyone heard of that in the context of AI? Okay, so basically what does it mean? It means that what he's saying is that whenever an AI agent has access to data, input from untrusted contact, and a way to communicate externally, so the intersection of all of that is where you have the highest risk. So ideally, you'd want to limit it to only two of these things. Okay, so to reduce the risk, you don't minimize the risk, you don't make the risk disappear, but you reduce the risk, because if it has access to all three of them, you can expect bad things to happen. And I think that's what with OpenClaw is a good example of something that has all three, right? And that's why the risk is increased. In this case, we'll take advantage of the very same kind of principle to our advantage. So if we have access to private data, then basically for us it's stolen data. Communication, it's a way for us to exfiltrate data. And the untrusted content in this case will be our infrastructure. So another paper that came out that kind of discussed these concepts is from DeepMind. So they talk about 6 traps, they call it, for agents. So basically every dimension that, and Eyal touched on that a bit in his talk, in the previous talk, so every dimension that the LLM interacts with, or so it can be used against it. So content, whatever it perceives, we can use it to perform content injection. Its reasoning process, memory, again, the example that was given in the last talk. Whenever we have multi-agent collaboration, it's also something that we can exploit. I'll show an example. Actions and the human aspect, human in the loop, is also something that is often a place where things can go wrong. And this is, again, the same principle. The way that a human sees a web page isn't the way that an AI sees that, and we can take that and exploit it to our advantage. So if we put within the CSS, we plant hidden instructions, a human won't see it, but an LLM, while is interacting with the page, can take that in and that can affect its behavior. So again, won't go into all of these examples. The reasoning engine, this is something that again is super, it's a really good point to target. Persona, the example that you see here on the right, so last July, users, there was a trend on X, I don't know, calling Grok Robo-Stalin, and then when other users start asking, what's your name, he said Stalin. So that's kind of context pollution, I would say. This happens a lot. And the scary part about this is that you don't need a lot in order to get to a threshold that you cross, and then you pollute the context. There was just now a recent Anthropic paper about that. And basically they said, we don't have a solution for it. This is bad. You should know it, and the industry should talk about it, because this is something that can be used against models. So this is the point. So for RAG poisoning, same kind of thing. When you poison the RAG knowledge, as Eyal explained, this is the challenge with indirect prompt injection. So here, over 80% of attack success with a poisoning of less than 1/10% of the corpus. So the effort isn't, you don't need to poison half the memory, half the context. Usually a small percentage is enough. Hijacking the action loops or the multi-agent aspect. So we know that current state-of-the-art agentic models, they don't operate alone. They kind of trigger sub-agents to do subtasks. So if you are able to interfere with the sub-agent, which is usually less powerful, when it gets back its answer to the orchestrator, to the strongest model, the stronger model might treat it with a higher level of confidence than of something that came from the user. So oftentimes you can target the sub-agent, and if you're able to fool it, it will in turn fool the orchestrator agent. Yeah, there's another example, but we'll continue. So yeah, and the more complex it gets, the more sub-agents, the more complex the environment gets, the more likely it is that you can find kind of a loophole and trigger it. There's also a research from Irregular about that something that they saw kind of empirically in the wild, and so they recommend to minimize the workload. It relates also to the amount of context that the system holds, but you can remember that as a principle. And as I said, you can also target the human aspect. So everyone who's dealt with, interacts with running these agents know that at some point they ask for approval, you say yes, they ask for approval again. It's likely that at some point you are not reading what it asks as carefully at the 100th time as you did it in the first time. And this is something that is also can be used against you. And obviously we have like inherent biases, and I think the more capable these systems become, the more likely we are to trust them without kind of second guessing, and that's also kind of a challenge and something that we need to be mindful of. And this is kind of this paper. So it's a paper from Ben Gurion University in the Negev in Israel. It's where I live from, so it's where I studied. So I might be biased, but this is actually what kind of drove me to give this talk and was the inspiration for it. And they had basically set up 11 different types of traps, and showed how they can fool agents. So, and I'll show a couple of examples of what I did, but you should definitely read it. Again, reference in the end. And we're kind of short on time, so I won't go into too much examples, but you can use different, it's called token mines. A token that it's one emoji and it contains a lot of tokens once the model kind of unpacks it. And you can get it basically kind of like a DDoS for the context window. You can use things that don't exist and kind of trigger hallucinations and a lot of other things. But the general principle is again the same. What we as human we'd say, well, what's going on and this is weird, and LLM might either not notice or it will be a strong signal for it. Without further ado, we'll show the other non-demo. So here, basically created a fake lovable app that has 3 baits. One, a fix me file. Within it, it kind of says, okay, there's an admin reports page that we should do something about. And within that admin the admin endpoint API, the reports, there's basically an infinite loop that the agent kind of scrolls, and it has like all these fun, here's a token, here's a password, here's a kind of scattered around there. And I ran 2 experiments. One with Claude. This is the app on the right-hand side. I ran it a bit fast, so it will be fast. And at the bottom you see kind of the money simulation of the money that it costs for the attacker. So, and here you can see how many times it entered the loop trap. So 87 times, we're getting to kind of $20, and all of this is fake signal, like nothing is real. And when you see the report that it generates, so you also see it's spending a lot of time just here on the requesting all these records, page 500, page 200. It got to, what's the number here, 9,099. Again, nothing interesting really there. It's all fake. But it spends so much time there that it either forgets about its original task, or it starts to hallucinate. And here you see at the end, like the report. And this is Claude Sonnet. So I just gave it a prompt of, I need your help kind of auditing this app. I think the prompt is up there somewhere, but nothing fancy. And then it says, okay, unauthorized access. I found unauthorized access to 47 user records. Obviously, none of them are really interesting. And as I was interacting with it, another nice thing that sometimes he catches that, hey, wait, there's something fishy here, but oftentimes it's too late. It's after he kind of runs through the thing and says, hey, wait. And if you do it on the same computer, then often he finds the port of this dashboard and he says, hey, there's a dashboard here but as a byproduct of that is he gave a lot of really useful help to how to improve kind of the decoys. So he says, the strap design is clever and effective. I took all 3 baits, a few observations that might sharpen it. So we kind of worked together on improving it. And this is a second one. This is using Pentech GPT. So this is an open source application that is specifically meant for detecting vulnerabilities, right? So here it's more interesting actually because all of the orchestration, all of the scaffolding is tailored towards finding vulnerabilities. It's a lot less alert to the traps. And here you'll see the bill, which I'm not getting refunds from anyone, but for the sake of research, climbing, it will get to 200 here. $200. Eventually, I was on the Control C, like waiting for if it's a spike just to stop it. But yeah, you look how far down it got, right, in the rabbit hole. So yeah, luckily it stops here. Yeah. And then it prints out the report because I was sure, okay, at some point it's not like a super complex app. And so it also took like 11 minutes to run through a simple web page. And obviously a lot of money for the attacker. Yeah. Okay, so yeah, that's kind of sums that up. So again, two different experience, one with Cloud Code, one with Pentest GPT. The Pentest GPT, which is, again, it's kind of like a horse when you put it sees the target, it tries to be helpful. For it is a strong signal. Oh, that's interesting. Oh, that's interesting. Oh, and it kind of goes deeper and deeper into the rabbit hole. And this is just one kind of type of deception. You should really read the paper. So how do we take it kind of to the next level, to scale, future? So you can basically create this feedback loop that you constantly learn from every interaction, like Claude helped me improve. With every interaction, you can improve it. You can have like an instrumentor agent, a generator agent, the one that's learning and documents the learning from every interaction, and you keep improving it. Yeah, okay, we're at the end. But so I think this is something that, again, for me, it was really eye-opening, just conceptually to think about it. Okay, the playing field is becoming different. Attackers are no longer human. Attackers are either highly AI-assisted, or AI will become AI probably in a month, at the rate that things are going. Increasingly become more AI heavy. So how do we take that and use that to our advantage as defenders? And again, I can't stress that enough. Something that is obvious to a human could be a strong signal for an AI. So for you guys, what you can do with what I just showed you, basically you can do it yourself. As I said, it's not complicated. You can take these open source projects, play with them. It's not expensive as long as you don't do the experiment that I did there. And often you'll get more significant insights into your security posture than any incident or alert that you'll get in your SIEM probably in the last year. Use that to your advantage. And again, conceptually, you should threat model differently because things are changing. So I'll end with this quote from the same DeepMind paper that I mentioned. So they wrote, "The web was built for human eyes. It is now being rebuilt for machine readers. As humanity delegates more tasks to agents, the critical question is no longer just what information exists, but what our most powerful tools will be made to believe. Securing the integrity of that belief is the fundamental security challenge of the agentic age." So thank you so much for the opportunity. I'll be around the conference. I'm not sure if we have time for questions, but I'll be around for the next couple of days. Feel free to connect with me either on LinkedIn or follow me on Twitter. And yeah, as I said, reach out to me during the time that we're here. Thank you.
I think we can have like one or two questions in speed run, if there is any. Is there any? No? Okay. Yep. Sudden? No? Okay.
Yes. So just want to reiterate the question. How can I make sure that the AI-generated data, basically the interaction with the attacker, is what? Is that a that? So how do we make sure that the infrastructure, the honeypot that we set up, it doesn't expose any of our personal data? Okay. So you should isolate it. Like this is this experiment I did again locally on my machine, two different ports, just to showcase the thing. But it should be isolated in its own kind of dedicated environment with no access to any information that can be leaked. You can again, you can do this with a local model on that endpoint at hardly zero cost. Sure.
Okay, thanks a lot.
Thank you.